The advent of quantum mechanics in the early 20th century revolutionized our understanding of the physical world, overturning many classical intuitions about the nature of reality. Not just confined to the realms of physics and engineering, quantum mechanics has also rippled through philosophy, challenging traditional assumptions and introducing a plethora of questions that have spurred considerable debate among thinkers. This article aims to explore these influences in greater detail, covering the realms of ontology, epistemology, determinism, philosophy of science, and even ethics and metaphysics. Quantum mechanics upends classical intuitions about particles and waves through the principle of wave-particle duality. For example, electrons, traditionally thought of as particles, can also exhibit wave-like behavior. This poses challenges for classical ontology, which seeks to categorize the fundamental building blocks of reality. Philosophers like Alfred North Whitehead have explored process-based philosophies to account for these kinds of dual properties. Similarly, phenomena like quantum superposition and entanglement have muddied classical views about locality and individuality. In a superposition, a particle can exist in multiple states at once, only collapsing into a definite state upon measurement. Entanglement allows particles to be deeply correlated, regardless of the distance separating them. Philosophers have used these phenomena to challenge traditional concepts like Aristotelian categories, positing instead that entities in the quantum realm might not easily fit into pre-established ontological brackets. The observer effect and the measurement problem in quantum mechanics throw a wrench into the classical view of epistemology. It appears that the act of measuring a quantum system can fundamentally alter the system itself. This brings into question Kantian or empiricist views about the possibility of objective knowledge, and it has driven some philosophers toward a more phenomenological or constructivist understanding of reality. Moreover, the inherently probabilistic nature of quantum outcomes casts doubt on whether science can ever provide a complete and deterministic account of the universe. Philosophers like Hilary Putnam and Bas van Fraassen have used these quantum quirks to argue both for and against scientific realism, igniting debates on the limits and scope of scientific knowledge. Heisenberg's uncertainty principle, which claims that pairs of properties like position and momentum cannot be simultaneously measured to infinite precision, has revived philosophical discussions around determinism and free will. Classical mechanics suggests a clockwork universe, but quantum mechanics introduces an element of randomness at the fundamental level. This has led philosophers like Daniel Dennett to explore more nuanced, compatibilist models of free will that can accommodate both determinism and indeterminacy. In classical physics, causality is straightforward. Effects will follow causes. But quantum entanglement challenges this view. Philosophers have engaged with questions about retrocausality. Can the future affect the present? And non-local causality. Can an event at one point instantaneously affect an event at another point? As they try to understand the implications of quantum phenomena on our view of causality. One of the biggest debates quantum mechanics has fueled in the philosophy of science is between scientific realists, who believe scientific theories aim to describe the world as it really is, and anti-realists, who believe theories are merely instruments for prediction. Quantum mechanics with its multiple interpretations, for example Copenhagen, many worlds, de Broglie boom, makes it difficult to claim a single true understanding of reality, leading to robust debates about the nature and goals of scientific enterprise. The existence of multiple interpretations of quantum mechanics has led philosophers to ponder the nature of scientific theories. Is a theory true if it is mathematically elegant but conceptually troubling, as in the many worlds interpretation? Or should scientific theories be judged by their intuitive comprehensibility, as some proponents of the Copenhagen interpretation would argue? While not directly in the quantum crosshairs, areas like ethics and metaphysics also have found new grounds for speculation. For example, the indeterminate nature of quantum events has been used to discuss the nature of moral responsibility and free will. Similarly, the quantum understanding of reality has been explored in the context of Eastern philosophies that do not rely on strict categorizations or deterministic frameworks. The reach of quantum mechanics extends far beyond the laboratory or the engineer's drawing board. By challenging our classical assumptions about reality, knowledge, and causality, it has provided a fertile ground for philosophical inquiry and debate, revitalizing age-old questions and introducing entirely new dilemmas. As quantum theory continues to evolve, so too will its philosophical implications, promising a future of continued interdisciplinary exploration.